Hello, everyone. Welcome to session 6, Design, Build, Use, Building a Computational Research Platform for Web Archives. I am Jefferson Bailey, Director of Archiving and Data Services at Internet Archive, and I will be presenting the first of 3 presentations in this session. Mine is titled Design, a Practical History of Supporting Computational Research on Web Archives. I would like to, of course, give a shout out to the organizers of Iipc Web Archiving Conference 2022. It's great to be here. Thanks for the opportunity to present. And also, of course, to Library of Congress that's hosting this event. Library of Congress looks suspiciously like my home office, but we do have the Jefferson Library behind me, so I guess it's relevant. So in the thinking of time and trying to keep this in our 10 to 15 minute window, I'm just gonna kick it off. But also, of course, a shout out to my co-presenters who will be featured in other videos in the session. Ian Milligan, Nick Ruay, Helga Holzman, Samantha Fritz, Cody Willis. This presentation is about our joint Archive It and Archives Unleashed project, which we're calling the Archives Research Compute Hub, or ARCH. And Ian will go into more details on the ARCH tool, and some of the users will talk about using the platform, which is session 3. And I'm here to give a little background on how it came about and just some more practical and conceptual details on how we've tried to support computational use of web archives in the Internet Archive. Let's get the slides going. So what can we say about web archive collections? I think many listening to the session know some of this already, but it's certainly relevant to providing web archives as data. Web archives have very complex curation and custodianship issues associated with them. They have significant affordances for supporting many different types of research, and they have many different limitations too. And we'll go through some of these in more details on later slides, of course. Obviously, web archives are quite large. They require unique and expensive expertise and infrastructure to support different access models, be that Wayback Machine style lookup all the way to derivative dataset creation. But at the end of the day, web archives will be the primary, if not the exclusive method for studying the first half of the 21st century. So it's quite important that we figure out how to make them as available as possible in as many ways as possible. The challenge that we'll talk about in this presentation is how to understand and address the technical, conceptual, and practical issues that are a little more granular than those high-level ones I just mentioned on the previous slide. In these issues, and how are we going to support data-driven use of these incredibly large collections? What are some of the technical issues? Well, the work format is pretty unknown and arcane to anyone outside of our web archiving community. It has lots of historical legacy reasons for it being the way it is. It's very, came about through how crawlers operate. It's very arbitrary as far as its containerization or concatenization or things like that. It can be any size. It has all sorts of stuff in it. There's just a lot of complexities to the work itself that we often have to demystify for users if that's what we are delivering to them for computational analysis. Obviously, web archives are quite large. Terabytes, petabytes, lots of data, and that imposes lots of challenges, not just on how we can process it, but how we can access it and how we can deliver it to people. The processing of work files themselves, but also, of course, tens, dozens, hundreds, thousands, millions of them. There's a lot of different dependencies for how you can process very large collections. There's a lot of material within a work file and within a web archive collection. Lots of different format types, lots of different information that is not human readable, lots of information that is only machine readable. So there's visibility issues. It's very hard to get a high level understanding of a large web collection without performing a lot of work. The concatenation I sort of mentioned, just how works are written, is very confusing to users, and sometimes that does have direct impacts on computational uses of it. Sometimes it doesn't. And then lastly, yes, there's a lot of different files and formats within a web archive. And often researchers are only interested in a certain one, or they might be interested in all of them, but how they can interact with them or process them is going to take many different tools. The conceptual issues, provenance of why a specific web archive collection, or even a large, huge crawl or a sort of arbitrary collection built from many crawls, the provenance is often hard to discern for users. So in some cases, they might not be interested in the provenance or the curatorial origins. In other cases, they will be. And it's our job to help give the context around why the crawls or why the collections have these shapes that they do. The acquisition, the actual activity by the crawlers, of course, there's link-based crawlers, there's browser-based crawlers, there's API harvesters. There's many different ways to acquire and harvest web published material, and they each have their own unique aspects to them that do have impacts on the collection. And those are issues that we need to be able to translate to researchers so that they know why the collections are of this character that they are. Of course, the borders in the web are very porous. You can have very tight scoping on a crawl, or you can have a arbitrary collection that you create for a researcher to do data mining on that is built from millions of crawls, from millions of partners, from millions of curatorial intent and ideas. So the borders are quite nebulous. Of course, many people think that the larger the collection, the more works, the more data, the better the research, or the more accurate the analytical job or the computational analysis. That is often not true, especially in web archive land, where more data can also often lead to sloppier research, or not necessarily sloppier research, but it can lead to more challenging data derivation activities. So that's something that we have to navigate as the research support people that are trying to help researchers use these collections. We need to help them understand that it's not always the more data will lead to better research. And of course, there are gaps within all of our collections, both intentional, like scoping and exclusions, a crawl that someone didn't want to get video, or a crawl that was only of PDFs. And sometimes these elisions are not obvious to downstream users. And so we need to be able to help them deal with these conceptual issues. What are some of the practical issues for us that are trying to provide the services and build programs for research support to support computational access to our collections? Well, where do people make these requests? This is often something people don't think about when they're pondering issues of how can I support computational research of our web archives? Well, how do people even ask? Many of us still haven't quite figured out what's the best method for making people aware of the potential of these collections. We can create data sets and post them. We can do, of course, outreach and promotion. But at the end of the day, somebody is just going to show up at your institution's website and they are interested in doing data mining on a web archive or born digital collection. How do they talk to? Is there a forum? Is there a contact email? What's the front door? So I think that very first level question is one that we all haven't quite figured out yet. So, but that's important. Scoping interviews, once somebody does know how to make a request for a collection or a portion of data or a data set, who are they working with? And is that person informed enough to ask the researcher the right questions, especially around some of these technical and conceptual issues that I outlined in previous slides? So this is a training and expertise and professional development activity that programs will need to consider. There is paperwork. Obviously, many of these materials are quite contemporary, and there's going to be researcher data sharing agreements, or however you might define them locally, that will need to be signed. Do you have these agreements on hand? Do you have legal resources or in-house counsel that can help craft MOUs or data sharing agreements or service level agreements or whatever you want to call them? But you will probably want to be having some sort of written agreement with the researcher if you're going to be giving them data that you have collected from the web. So thinking through that is an important piece as well. course, the budgeting and the staffing, these two next bullet points. We can't spend all our time or a significant amount of staff time supporting one single researcher. We need to be thoughtful about building programs that can serve many researchers in many ways without having deleterious impact on our own staff time, our own resource budgets and things like that. And of course, there's developing programs around this. How do you staff them? How do you fund them? What's the cost model? What's the business model, et cetera, et cetera. So I think there's a number of practical issues to think through as we design programs. We, the community, design programs to support this this growing type of use of our collections. There's a couple of different service models. We've explored many of these at Internet Archive in various ways. Some of them are pretty easy and some of them are pretty complex. Bulk data model is just give people a lot of the raw data, generally a whole bunch of work files, ship them on drives, make them available for download, whatever other methods you might think of. But at the end of the day, you're just giving people access to very large portions of data, and they are taking it and doing whatever research and analytics that they might need to do. There's put the data into a defined environment for them to work with there. This could be, something like in AWS or in a commercial cloud service. It could be in a dedicated, restricted access infrastructure environment within your own institution. It could be in their cyber infrastructure, high performance computing cluster that they have in their campus or in their organization. So there's a couple of different models, but essentially you're depositing data into a place instead of just making it available for them to take. There's the roll your own model, which is building custom tools for specific researcher types of research or data analysis. These are very bespoke, very one-off. It's write a little script or some kind of notebook or a model or something where that is very specific to the data that they're looking at and very specific to the type of research question that they're asking. Building middleware is similar, but a little more repurposable across many different types of disciplinary interest or many different types of research questions, but still providing a sort of extensible way to interact with a web archive collection in data form. Prepackaged model is giving people data sets that you've already created that might answer questions they have. There's the support model, which is of course having engineering or technical staff that can actually do analytical work for them under their direction or with their guidance. And then there's the community model, which is sort of building communities and cohorts of practice that can share both tools and share knowledge of how to work with web archive collections for data-driven research. A couple of quick examples of some projects we've done. We worked with a couple of academic institutions who are interested in studying industry classifications. The web turned out to be a great way to get them access, not just to how public companies were defining themselves on the web, but also how private companies were by looking at their website homepages. This is over almost 1 million different corporate homepages over almost the whole extent of the web archive. It was very complex extraction jobs. So we're extracting text from corporate homepages at a defined frequency for many years for obviously a lot of different homepages. They also kept changing the nature of the text that they wanted, how deep the text extraction would run, what pages were included in the request. So it got very complex very quickly. And it was a good lesson learned about how scoping the request and what they were interested in farther upstream, so we weren't duplicating a lot of our data extraction work internally. Another project was working with the Paracrawl, which is looking at parallel quora for languages. The web archive turns out to be a great text resource for similar text in different languages. Since a lot of early web, they translated their own web pages into multiple languages. So it's a great comparison data set for machine translation. So that was a very great project where we were extracting specific languages from the web archive in that had the same web page in multiple languages. So that was cool. And the News Measures Research Project was a great one where they actually did crawling of local community online newspapers and then analyzed that to see, to ask various research questions around the health of local news. I like this one because it was not just use the web archive, it was also build the web archive and then do computational research on the collection that they had created. So they created a collection, they ran crawls, they were identifying the content that they had crawled that they then wanted to analyze. They're using a number of our various APIs to request data sets from us. We create them and post them, and they use the API to find the data sets. They pull them down locally. They run second level analysis of them, and then they create visualizations and of course publish and things like that. So a very cool project. I'm at 15 minutes, so I'm going to speed through this. I put this in all my slides about computational research. One of my favorite quotes, which is researchers do not necessarily need huge sets of data to do interesting work. They need flexible data delivery services, different formats based on different searches for different kinds of research at different times. It's from a Google report when a Google project where they're supporting digital humanities work. We have tried we have tried to enact this flexible delivery model, doing things like sort of Kibana dashboards where you can sort of very easily do some quick querying of extracted data. We have done APIs, Jupyter notebooks. We've done prepackaged data sets around named entities, around graph networks, around specific metadata pieces. We've done training and some of our own software tools that we've created to do this computational work internally. So we're sharing that in open source software and then doing training around it. And of course, trying to provide, more formal paid services, or not paid services. Some of them are free, some of them are paid, some of them are funded by grants. Trying many different models to see what works best for different research communities. The one that we're talking about more in this presentation is our Archive Research Compute Hub. There's our great logo that we recently came up with. Ian will talk more about that, but as I wrap up this slide at 16 minutes, practical lessons that web archives will extend and enhance other collections that you have. So find complementary non-web collections that you think can work well alongside the web archive. Web archives support research uses beyond the documentary content. A lot of people still interested in the documents and the evidence, but there's incredible graph analysis. There's the history of software platforms that are all represented within the collections. So I think there's far more than just our traditional humanities and documentary based research that our collections can support. They have many different unique values for many types of analysis. So as programs trying to build research support, we should be expansive in documenting and promoting all these various use cases. We should be well versed in the imperfections and elisions within our web archive so that we can work with researchers when these issues disrupt their own research processes. And researchers have analytical interest, not direct requests. So there is a lot of research interviews, support, and back and forth to working with data-driven research communities. Other practical lessons is that our collections are not agnostic to scholarly, or they are agnostic to scholarly inquiry. We have humanities, we have poli-sci, we have comp-sci. Basically, any discipline can use web archives. So I think that's a really unique. It's not like a collection of digitized poetry. It's very heterogeneous and therefore can support almost any type of research. Topic, question, discipline. There's methodological issues, which we've covered. Web archiving tooling processes and concepts. I think we know them because we are in the web archiving community, but it is arcane jargon to anyone outside of it. We need to be thoughtful about how we communicate with folks. And then they're very large data volume wise, but more data isn't better data, as we talked about before. That's it. I went a little long, but thank you for attending. There's my title and there's my email. And a huge thanks, of course, to the Mellon Foundation, which has funded our Archives Unleashed and Archive It Integration Arch. And we're doing a whole lot of datathons in the next year and two. So thanks to the other funders. And of course, thanks to our many Archive It beta partners that are testing Arch right now. So thanks. Bye, everyone.